Alrighty, hello there mathematicians. Okay, today's objective is students will be able to simplify expressions by combining like terms. And let's actually put that in parentheses. Like terms. Okay, if you don't have that yet, make sure you hit pause. Alright, let's go through. You guys have this box in your notes. The first arrow is pointing to the 3. What is the 3? What's the name for that? Well, the 3 is touching in front of a variable, okay? And we know touching means being multiplied by. So whenever we have a number that's being multiplied by a variable, we call that number the coefficient. Okay? Okay, the next thing. We have an arrows going to both this 3x and the negative 2. Okay, 3x and the negative 2. Well, these are called terms. Okay, these are called terms. Terms, and we're going to learn this today, terms are separated by addition or subtraction signs. Okay? So like this one, if we separate, okay, we always separate before the addition or subtraction sign. The 3x is a term, and the negative 2 is a different term. Okay. Next, we have an arrow going to the y. The y is called, we should know this, a variable. Okay. And then we have an arrow pointing to this entire thing. Well, what would all of this be? Okay, this entire thing is called an expression. Okay, and we should know that. Okay, an expression. Now, expressions, you notice, do not have a what? They do not have a, so no equal to sign. If this had an equal to sign, then it would be called an equation. Okay? All right, that's the first part. Let's do a new page. Okay, I want to go over the conceptual understanding of what like terms are. So you can actually just put your, this part, I don't think you have room in your notes, so right now you can just put your pencil down and just really watch this, okay? So, let me give you an example. First of all, we're talking about like terms. I want you guys to really understand what like terms are, okay? Let's say that I have a student that has a low grade, and so they bring me in 2 apples. They're like, here, Mr. Erwin, here are 2 apples. Can you do something about that grade of mine? And what do you think I'm going to say? Clearly no, okay? What I'll say is office hours, retake some quizzes. All right, another student comes along, also has a low grade. They decide to bring me in, their grade's really low, 5 bananas. 5 bananas, okay? So my question to you is, how many total pieces of fruit did I brought to me? Okay, well the answer was 7 total, right? But if I ask you 7 what? Okay, would you say, I mean, can you just combine the apples and bananas? No, they're not the same type of fruit, right? If you say 7, what would you say? If, let's see, if I combine the word apples and bananas, it might be like 7 banapples, right? That doesn't make sense. You cannot combine the apples and bananas. They're not alike. They're not the same. Okay, now I want to relate this back to math. So let's say the apples. How could we represent 2 apples? Okay, and again, you guys can just watch this. Okay, we could represent it as 2A. How could we represent the 5 bananas? Well, we could represent it as 5B. Okay, so now, again, we can see we already knew that these were not alike. Okay, now we have 2A plus 5B. They're still not alike because they don't have the same variable. Okay, they're different variables, so we cannot just combine them. Again, we can't have 7 banapples. Okay, you cannot combine them. But let's say more students came along, because it's getting to be towards the end of the semester. Students really want to raise their grades, which the easiest way is to come to office hours and start studying. Okay, but let's say another student comes along, they bring me 3 bananas. And then another student comes along and they bring me 1 apple. Okay, now what of these could we combine? Well, how many total apples do we have? Remember, the A's represent the apples. You have the 2 apples and remember, if there's not a number there, what number is actually there? It's a hidden 1. So how many total apples did we have? Well, 3 apples, so we can show it as 3A. How many total bananas did we have? Well, 5 bananas and 3 bananas is a positive 8 bananas, so 8B. Okay? So if they have the same variable, you can combine them. Okay? Okay, you guys should have this part in your notes, so be ready to write along and think with me. Terms. We already kind of talked about terms, but terms, what did we say they were separated by above? Okay, should have said they're separated by addition and subtraction. So terms are just this. They're just pieces of expressions. Pieces of expressions separated by addition and subtraction signs. Okay? So that's what terms are. Okay? All right, like terms, and you have this in your notes. In order for terms to be like terms, they must have 2 things. First thing, and these you really have to memorize these. They must have exact same variables. And put that S in parentheses, because sometimes they might only have 1, sometimes they might have more than 1. Okay. The second rule, in order for things to be like terms, again, they must have both of these, okay, is that the same variables must be raised to exact same powers. Okay? So here's the key on this. Same variables, same powers. Okay? Those are the 2 rules for like terms. Okay, if you don't have that down yet, hit pause and get that down. Okay, well, everyone, this is not in your notes, so you need to get out a separate piece of paper and get these notes down. So right now, hit pause, make sure you get out a separate piece of paper that you can keep with your notes packet. Okay? Alright, assume you have that piece of paper out. At the top, put ordering terms, and you can even put objective 122 at the top. Okay, this is one of the things that students are struggling most with when it comes to combining like terms. So I want to go over the rules for how we order the terms. Okay, the first thing that we need to do is add up exponents on variables only. Ooh, that was an ugly looking. Only. Okay? Let me erase that. Okay? Now, here's the key on this. That the highest sum goes first. Oops. Highest sum goes first. And we'll give you examples to understand what that means. Okay? Second kind of rule with this is this. If, so let's just write if tie. So if we have a tie, put in alphabetical order. Okay, so if there's a tie, we're going to put them in alphabetical order. Okay? All right, let's do a few examples of this. So again, you're continuing your notes on the separate sheet of paper. So let's do an example of, let's do negative 4y plus x. Okay? Now, we have to ask yourself, what should be the order of these terms? Should it stay that negative 4y goes first, and then the plus x, or should it be plus x, and then the 4y, negative 4y? Okay? Well, we look at the exponents on only the variables. If there's no exponent on the x and the y, what is actually there? Okay, and you have to know this. If there's no exponent, there's actually a hidden 1 on each one of these. It's y to the first power and x to the first power. Okay? So, we would add up the exponents on this first term. Well, what do they add up? Well, there's only 1. The exponents on this next term, there's only 1. Okay, so it's a tie. So because it's a tie, we have to go to what? We have to go to alphabetical order. So we would need to change this. X comes before y, so it would be x, because it's a positive, right? This plus means it's a positive x, so we just, there's a hidden positive there if nothing's there. It's a negative 4y, so we have to write minus 4y. Okay? So this would be the correct order of these. Okay? Let me give you another one. Example 2. Okay, what if we give you negative 5y plus 3x squared minus 2y squared. Okay. What order would these need to go in? Well, you start off with the highest exponents. Okay. Well, here you have an exponent of 2 on the x, and you also have an exponent of 2 here. Those are the highest. Well, now we have a tie with the highest. So which order does it go in if we have a tie? Well, we go to alphabetical order. So the x has to come first. So this positive 3x squared needs to come first. Then remember we had a tie, so we go to the y squared, so it'd be minus 2y squared. And then we have this y to the first power, which has got to come last, and it's a negative 5y, so we have to write minus 5y. Okay? Alright, let's do another example. Example 3. What if we give you, let's see, negative 3n plus 10mn plus 4m. Okay? So we have to ask yourself, first, add up the exponents on the variables for each term. Okay? Again, for each term. So, there's a 1, here's a 1 and a 1, here's a 1. So which one has, if you add up the exponents, like this one has 1, this one has 2, this one has 1. Okay, so which one's going to come first? Well, the one with the highest sum. So this 10mn needs to go first. Then the n and the m with an exponent of 1 are a tie. So we have to go to alphabetical order. So MNOP, so M needs to come first. So we have the plus 4M. And then we have the negative 3N, so minus 3N. Remember you guys, a negative and a minus mean the same thing. A negative number we can just write as minus. Okay? So, we're going to keep practicing these, but I want to go over a few examples of the rules for how to order these, because that's where students are struggling. Okay? Okay, so this example should be in your notes. 4x plus 5y minus 6x plus 5y squared. First thing that we need to do is separate the terms. So when we need to combine or combine like terms and simplify, separate the terms, and we put bars before, and this is the key, before the addition and subtraction signs. And that just kind of helps us see what all the different terms are. And I like to kind of angle mine a little bit. Okay. Okay, so let's put that key point in that we use. Okay, we use bars before the addition and subtraction signs. Again, hopefully yours is a lot neater than mine. Alright, now we have to ask ourselves, are there any terms that are alike? And I always just start with the first one, the 4x. Are there any terms that have an x raised to the first power? And you should say, yes, clearly. Okay, the negative 6x. Okay, so I'm going to underline both of those to kind of mark those. Oh, those are the same. Okay, next, are there any terms, so I go to the next term, the positive 5y. Are there any other terms that have a y raised to the first power? The answer, no. The 5y squared, same variable, but it doesn't have the same exponent. You have to have both rules true. Okay, so this is a separate term. I'm just going to put a box around it, and then I'm just going to leave that 5y squared blank. So now we have to ask ourselves, okay, which term would come first? Would the x's come first, the y's come first, or the y's to the second power come first? Okay, and we just learned that you go with the highest exponents on the variables. So this positive 5y squared is going to come first when I'm writing my answer. 5y squared comes first. Okay. Now, what's going to come next? The x's or the y's? Okay. Well, it's a tie because it's, they both have x. This is x to the first power, y to the first power, so it's a tie. And we're actually going to combine these two. All right. So the x's have to come first. Now, combine. What does combine mean? What operation? If you combine, let's just say $10 with $5, how much money do you have? 15. What did you do with those numbers in your head? You added them. So combine means to add. So on your calculators, just do 4, okay, this 4x, 4 combined with, so addition, 4 plus this negative 6, because we are combining these two terms. When you do that, you get negative 2, and then you keep the x with it. Okay, that's our x term. So we have minus 2x, and then this plus 5y just stays. Okay, this is our answer. And I look at it, and it's like, okay, can I simplify anything else? No, there are no more like terms. Okay, so this would be our final simplified answer. Okay, let's go over another example. Okay, find this example in your notes. Alright, so again it says to simplify, so we need to combine these like terms. So I'm going to put bars before the addition and subtraction signs. Before. The other thing, you guys, and this is key. Okay, what number is in front of this x right here? What number is there if there's no number in front of a variable? Okay, you should know that there is a hidden 1. Okay, so actually make that a key point. So just above this, just write KP, okay, and just write to first put in hidden ones. Again, I don't have my stylus pen, so handwriting's even worse. Alright, now we got to combine like terms. So I start off looking at the first term, 4y squared. So I ask myself, are there any other y squared terms? And the answer, yes, this one right here. Okay, so those are going to be combined. Next, I look at this y to the third, the 5y to the third. Are there any other y to the third terms? The answer, no. Okay, negative 6x. Are there any other x terms? The answer, yes. So I'm going to circle. I'm just marking these differently. Okay. Now let me show a common mistake on this. Okay, say I rewrote that term and I'm going to circle it and I do this. What do you think might happen with that? Okay, when you go to combine like terms, what happens all the time. When students get sloppy with their marking of the terms, students begin to think that this minus is actually now looks like a plus because your circle goes through the minus and makes it look like a plus. Okay, so you cannot, you got to be really careful when you mark these terms. All right, so now we have to ask ourselves, which one comes first? Well, the highest exponent. This 5y to the third has the highest exponent. So that's got to come first. Okay? Next, our y squared's got to come first. Or come next. Well, we got to combine these. 4, right here, this 4y squared combined with 5y squared. 4 combined with 5 is 9, a positive 9, so we write plus 9y squared. Okay. Next, we have two terms left. Okay, and some students like to lightly cross these terms out once they've kind of combined them. I think that's fine, but it makes it hard to check your answers in if you cross through them, especially if you cross through the signs. Okay. Next, we have the x terms. Let's see. I have a -6 combined with a -1. Okay, so -6 combined means add, -6 plus -1 will get you negative, so I write minus, -7x. Okay, now if a student got this, -6x, what did they do? What caused this mistake if they got a -6x? Okay, you should say, well, they forgot to put in a what? They forgot to put in that hidden 1, and they didn't combine it with that -1. Okay, this would be your answer for this example. Okay, let's do another example. Again, if you have questions, hit pause, write the questions in now. Okay, so if you're still confused on okay, why did the 5y to the third go first? Draw an arrow, write a question mark, and write that question in. Okay, on the next page it says, find the page where it says indicate whether the following are like terms by answering yes or no, and then explain why. Okay, and the first example that it gives you is 3a plus 4a squared. Okay, are these like terms, and why or why not? Okay, remember the two rules for like terms. They have to have the exact same variable. Do these have the exact same variables? Yes, they do. They both have an a. The second rule is that the variables must be raised to the exact same power. Are these variables raised to the exact same power? The answer is no. So this one, the answer is no. And then it says, comma, because you guys need to explain in your own words that these are not like terms because they do not have the exact same power or the exact same exponent. Hit pause now and write that in your own words. Okay. Alright, you should have written the explanation. The second example it gives us is 4ab plus 9abc. Question, are these like terms? Okay, think about that. Think about the two rules that both must be true. Exact same variables raised to the exact same power. Do they have the exact same variables? Answer, no, they don't. This one has an a and a b. This one has an a and a b. But this one also has a c. Okay? This one's missing the c. So the answer to this one, are they like terms? And the answer is no. And it says, comma, because you need to say in your own words that something about they do not have the exact same variables. The one has a c and the other one doesn't. Okay, hit pause, get that down now. Alright, the last example for determining whether they're like terms is -2xy plus 6yx. Okay? Alright, question is, are they like terms? Okay, use your rules. Do they have the exact same variables? The answer, yes, they both have the exact same variables, x and a y, x and a y. Second question that also must be true. are the variables raised to the exact same powers? The answer, x to the first, x to the first, y to the first, y to the first. Yes, they are. Okay. Now, some of you, a lot of you, are probably thinking, no, they're not like terms because they're not in the same order. Did we have any rule that tells us anything about being in the same order? No, we didn't. So, these are in fact like terms. So yes, comma, because. And I want you, on this one, let's all get the same thing down. That they have, okay, the same variables. Okay, they have the exact same variables. Yes, they do. That's a check. Okay, also, the other thing is that the same variables have same powers. Okay. And kind of a key point on this that probably tripped some of you guys up is that the order does not matter. Right? With multiplication, order does not matter. That is the commutative property. Right? Okay, find this example in your notes. You may have to flip a couple pages. So hit pause now, find this example. When you found it, unpause it. Okay, I'm going to go a little bit quicker through this one because we've already done some that are similar. We got to simplify, so we need to combine like terms. So I'm going to put bars before addition and subtraction signs. Okay, and then we're going to start combining like terms. So I asked myself, I just looked at this first term, 4a squared. Are there any other terms that have an a to the second power? Okay, yes, these first two have an a to the second power. Okay, next term that's different is I have this positive 9a. Are there any other terms that have an a raised to the first power? And the answer is yes. We have that one and that one. Okay, and then that negative b to the first power, there are no other b's raised to the first power. Okay, go with the highest exponent, so the a squared. When you combine the 4 with the 8, you get 12a squared. You notice the exponents are not changing. We keep the a to the second power. They're not changing. It's just like before. If you have 5 bananas plus 3 bananas, okay, it would be 8 bananas. It would not be 8 bananas squared. Okay, it's just the 8 bananas. When you're adding and subtracting, the exponents do not change. Okay. Next, we have to kind of ask yourself, well, what's going to come next? Is it going to be this combined a term, or is it the b term here? Well, that's a to the first power and b to the first power. Okay, so it's a tie, so you go to alphabetical order. All right, so we got to do the a's next. So the 9 combined with the negative 13. 9 combined with addition with negative 13. So 9 plus negative 13 will give you a negative 4. So I write minus 4, and then you just keep that a. And then lastly we have the minus 12b. Okay. Cannot combine any more like terms, which you should always check in your final answer. So that is the simplified answer. Okay. Okay, let's look at this example. This one's a little trickier. Okay, we have a b squared plus b over 5. Okay, plus 2/5 b. Well, what's in front of this b squared? There's a hen 1, right? What's in front of this b right here? Well, there's another hen 1. Okay, now, I want to ask you, are there any like terms here? Are there any like terms? Well, what's the exponent on this b right here? What's the exponent? A 1, right? What's the exponent on this b right here? A 1. Those are like terms. Okay. Now, to combine them, I think it's a lot easier to rewrite this. So we're going to rewrite this. This 1b squared isn't going to change. So 1b squared. How else, we've gone over this in the last unit, how else could you rewrite 1b over 5? My hint, write it as a coefficient. Okay, well, it would be, so plus, it would be, just pull that fraction out in front. 1/5 b plus 2/5 b. Okay, now, separate the terms. These are like terms. Those are the same, b to the first power, b to the first power. Okay, so our b squared is clearly going to go first. So I'm just going to rewrite it as b squared. You could put the 1 in front if you want. You don't have to, though. So b squared. Now, 1/5 plus 2/5. Common denominator already, so we can just add the numerators. So we would get plus 3/5 b. Okay? So here's the key. Don't let fractions throw you off, right? This is still b to the first power, b to the first power. They're like terms. You got to combine them. Okay? And then it's just pulling this coefficient, this 1 over 5, pull that as a coefficient out in front, and then you can just add the 1/5 plus 2/5. Okay? Alright, I think one more example. Okay, find this example. So let's go through this one. W to the first power. So I'm asking myself, are there any like terms? W to the first power? Are there any other W's to the first power? No. Okay. Next, we have 3xy and then negative yx. Are those like terms? Are those like terms? Okay. The answer is, well, let's look at it. Do they both have an x and a y? Exactly an x and a y. Yes, they do. Is the x in both raised to the same power? Well, x to the first power, x to the first power. So yes, so far. Is the y raised to the same power? Y to the first power, y to the first power. They have the exact same variables raised to the exact same powers. So are they like terms? Yes, they are. Okay. So, and you may be wondering, well, they're not in the same order. Let me ask you this. Well, they're touching, right? X times y are touching, so it's multiplication. Is 4 times 5 the same as 5 times 4? Answer, yes. Okay. Order, remember with multiplication, order does not matter. What property is that? It is the commutative property where the numbers can move around. So these are actually, I'm going to separate, these are actually like terms. Okay, what's in front of this one right here? It is a hidden 1. Okay, now we have to determine which one would come first. Well, add up the exponents on the variables. So I know I'm going to be combining these two. So if I add up the 1 and the 1, that is a 2. This one only has the 1. So what's got to come first? The xy term has to come first. Well, when you combine a positive 3 with a negative 1, 3 plus negative 1 will give you a 2. Now, when we rewrite it, we should write them in alphabetical order. So we're going to write 2xy, and then we just had this plus 4w. Okay? That is your simplified answer.